All right, so we're going to start off chapter 13 with a section on what we call trigonometric identities. A trig identity is basically just a formula where everything is true, no matter what you plug in. So an identity means that it is true no matter what angle you plug in. And we've got all these different angles that we could plug in all the way around the unit circle. Okay, so we've got some basic trig identities that we're going to look at. They fall into 5 different categories. First category is the quotient identity. Remember, quotient is like division. So there are 2 of these. And a lot of these are going to be new. Some are familiar, but a lot of them are pretty much new. So our first one is this: tangent is equal to sine over cosine. And as I write these down, I'm going to kind of explain exactly where they came from. So hopefully you guys have volume and you're actually listening to this. So tangent, remember in a previous section in chapter 12, tangent was defined to be y over x. Well, we also learned in the unit circle that the y value goes with sine and the x value goes with cosine. So this really is just a fancy way of writing y over x. So tangent is equal to sine over cosine. This identity holds as long as cosine isn't 0, because we're not allowed to divide by 0. And then we have a really similar one for cotangent, because remember, cotangent is the reciprocal of tangent. So the reciprocal just means that these 2 will flip. Okay, and very similar to this will be true as long as sine isn't equal to 0, because again, we can't divide by 0. So those are your 2 quotient identities. Those are really common. Those will pop up a lot. Next, we have the reciprocal identities. These ones you guys should know. It shows that cosecant, secant, and cotangent are just the reciprocals of sine, cosine, and tangent. So we've been doing that for a while. All right, so this says that sine is the reciprocal of cosecant, cosine is the reciprocal of secant, tangent is the reciprocal of cotangent. Okay, so we can also write them the other way. We can say that cosecant is the reciprocal of sine, secant is the reciprocal of cosine, and finally cotangent is the reciprocal of tangent. Okay, so again, those ones are not new. Those ones we've already seen, just those reciprocal identities. So if you know one, you can just flip numerator and denominator and you automatically know the other one. Pythagorean, these ones are new. Okay, so I'm going to write the identities in black, and then kind of the explanations are going to be in some sort of other color. So the actual identities will be in the black ink. So Pythagorean identities, here's the first one, and then I'm going to explain it. Okay, so the reason they're called Pythagorean identities is because they come from the Pythagorean theorem. And so what this one comes from is x squared plus y squared equals r squared. So that's the Pythagorean theorem when you're looking at a unit circle. When you are looking at a unit circle, remember, x goes with cosine, y goes with sine, and then the radius is always 1 if you're in a unit circle. This, see how the squared is on the inside like that? That's just the notation that we use for trig. Instead of putting the squared after the theta, we put it on the inside. That way it shows that the entire cosine is being squared and not just the theta. So that's just notation that we use. All right, now we have this other one where we take these identities and we divide them through by x and then y. Okay, so this one, I'm going to explain this one first. So remember, the radius is just equal to 1 in these. So if we took this entire thing and divided everything through by x squared, it would turn into this. If we took everything and divided it by x squared, okay, so everything that we had here and dividing it through by x squared, and I'm going to write on the left what that all simplifies down to. So x squared over x squared simplifies just to 1. Plus, and then y over x, remember, is tangent. So if I have y over x, it just ends up being tangent squared, and then it equals 1 over x, that's the reciprocal of cosine, which is this, so that's secant. Okay, so this is our second Pythagorean identity. Third Pythagorean identity, again, I'm kind of writing the explanation over here in pink. If I start with this original one, knowing that r is 1, and then divide everything through by y instead. So if I divide this through by y squared, same thing with this one, I'm just dividing every single piece by y squared. And then I'm going to write what that becomes. So x over y is cotangent. Plus, of course, this reduces down to 1, just like this did. And then the reciprocal of y, that's the reciprocal of sine, which is cosecant. So these three are known as your Pythagorean identities. They come from just kind of manipulating the Pythagorean theorem. All right, next, co-function. So co, meaning like sine and cosine, are co-functions of each other. Tangent and cotangent are co-functions of each other. And what this basically amounts to, you know how sine and cosine are just these kind of repeating periodic functions over and over again? The only difference between sine and cosine is really just a phase shift. So that's what these co-function identities tell us. Tell us the only difference between sine and cosine is a phase shift. So we have sine of pi over 2 minus theta is equal to cosine. So that tells us that the cosine graph is just a phase shift of a sine graph. And then we have the exact same thing for cosine. Tells us that the cosine graph is just a phase shift of the sine graph like this. And then we have one for tangent and cotangent. Oops, cotangent. There we go. These are a lot less common. They might pop up every once in a while, but the ones that we have above are the ones that are used the most. And then negative angle identities. Okay, so if you have sine of a negative angle, that means it's equal to the negative value of sine. So let me show you. I'm going to flip back to the unit circle just so that that identity in particular makes sense. So we've got three of them, and they're a little bit weird to wrap your head around. So we have our unit circle right here. So it says sine of a negative angle is equal to the negative version of the sine of that angle. So let's look at 30, for instance. Sine of 30 is 1/2. If I take the sine of negative 30, it's negative 1/2. Okay, sine of 45 is root 2 over 2. If I take the sine of negative 45, it's negative root 2 over 2. So what this identity tells us is that if we want to take the sine of a negative angle, it's the opposite of the sine of the original angle. That's the first one. Second one is cosine. Cosine actually says the sine of the negative angle is just the same as the cosine of the original angle. And I'll show you that on the unit circle as well. So if I take any of these, cosine of 30 is positive root 3 over 2. Cosine of negative 30 is also positive root 3 over 2. So that's not on the screen. There we go. Right here. Same thing with 45. Cosine of 45 is root 2 over 2. Cosine of negative 45 is also root 2 over 2. So those values are the same. And then tangent is also the opposite, just like sine. So these two types are a lot less common. You'll see we're going to be using the first three a lot. So that was the majority of our time, was just writing those identities down and kind of explaining them. I'm going to walk you through two examples that show you how to actually use those identities. So find tangent if we know secant, and then we know where the angle lies. So that's really important to know where the angle is going to lie. This is your third quadrant between 180 and 270. So what we know about tangent is that tangent is negative in the third quadrant. Okay, so in the third quadrant, tangent is negative. So we know that our final answer is going to come out negative. That's why they tell us what quadrant we're supposed to be in. Okay, so tangent and secant. Basically what you want to look for is any identity that combines tangent and secant. So I'm going to run through this the long way. So back to the other page. This doesn't combine tangent with secant. This doesn't have either one of them. None of these identities have tangent and secant in the exact same identities. And we find this one. This one right here, the second Pythagorean identity, combines both tangent and secant in the same identity. So when you have them all in front of you, it's going to be a little bit easier to spot which one you're supposed to be using. So we're going to use this right here. So I'm just going to rewrite it so that we know exactly where we're plugging in all our numbers. Okay, now I'm just going to plug in this. Secant is -2, and we're going to solve for tangent. So 1 plus tangent squared of theta is equal to, and I take that -2 and I square it. 'Cause remember, this squared just means that you're squaring the whole thing. It's just a notational thing for our trig functions. So this, we've got -2 squared, that ends up being 4. I'm going to subtract this one from both sides. So I have tangent squared is equal to, this is 4 minus 1, which is 3. And then finally I take the square root of both sides, so I get just tangent by itself. And so I end up with tangent of theta equals either plus or minus the square root of 3. Because remember, when you square root in a situation like this, you should always have plus or minus. But because of this, I know I'm in the third quadrant, and I know that tangent is negative. So that means that I am using the negative square root of 3 as my final answer. Very important that you have the plus or minus to begin with, and that you know what quadrant you're supposed to be in. Okay, really similar for this one. Sine, we're given cosine, and then we're given this right here. So this is the second quadrant. And when we're in the second quadrant, sine is positive. Okay, so we know that when we get down to our final two options like this, we're going to choose the positive answer. So sine and cosine, the ones that relate sine and cosine together would be another one of our Pythagorean identities. We know that cosine squared plus sine squared is equal to 1. So we're going to use that. Okay, so I'm going to plug in what I have. Negative 1/2 squared plus sine squared is equal to 1. So this, when I square negative 1/2, I get 1/4. So I'm going to subtract that from both sides. So these will cancel. And I end up with sine squared is equal to 1 minus 1/4, leaves us with 3/4. And then I square root both sides. So when you square root both sides, make sure you've got a plus or minus. Square root of 3 doesn't come out evenly, so we're just going to leave it as the square root of 3. And then square root of 4 comes out to be 2. So for our final answer, looking at this quadrant restriction, we know sine should be positive, so we're going to take the positive square root of 3 over 2. And that would be your answer. All right, let's look at the last little section here, simplifying expressions. So what we're going to do when we simplify expressions, we basically want to get everything written in terms of sine or cosine. Okay, so that's what it means to simplify an expression. So sine and cosine are like our main trig functions, so we want to get everything written in terms of them, and then we can simplify them up. So we've got sine theta, so that already is sine, so we're just going to leave it. And then in parentheses, we've got cosecant, which is the reciprocal of sine. That was one of our reciprocal functions that we had on the previous page, minus, and then this already is in terms of sine. Okay, so we write it like that. Now what I'm going to do is I'm going to distribute this sine. So distribute here, distribute here. So sine times 1 over sine, what's going to happen there is the sines will cancel, and this right here will leave me with just 1 minus, and then sine squared times, sine times sine is sine squared. Okay, so the last thing I can do to simplify this down, this actually ends up being equal to cosine squared. And so I want to remind you of this Pythagorean identity right here. So if I had this identity, which I showed on the previous page, if I subtracted sine from both sides, I would have this. And so that is equal to cosine squared. All right, so again, just showing you where that came from. That'd be subtracting sine squared from both sides. So if I have 1 minus sine squared, which I have right here, according to this, that is the same as cosine squared. So you want to get it as simplified as possible. It should definitely be in terms of sine and cosine, and you want it to get, like if you can get one term compared to 2 terms, then you want to. You want to keep simplifying down. Okay, here, we want to write this in terms of sine. So cotangent squared minus tangent squared. So let's write cotangent squared. We are going to write that as cosine squared over sine squared. And then minus tangent squared is sine squared over cosine squared. Okay, so these ones are a little bit weird. These ones we're subtracting, but we don't have a common denominator. So what we're going to do is we're going to get a common denominator. So this one has sine squared, this one has cosine squared. So our LCD would be cosine squared sine squared. So I'm going to multiply this top and bottom by cosine squared over cosine squared. Multiply this one by sine squared sine squared. Okay, so now I get this common denominator. So this one, cosine squared times cosine squared, is going to be cosine to the 4th minus, and then this will also be sine to the 4th, over, now I have this common denominator of sine squared times cosine squared. And we're going to keep simplifying. There's always more to be simplified. So this one, cosine to the 4th minus sine to the 4th, this can actually factor down into cosine squared plus sine squared and then cosine squared minus, sine squared. So it's like a difference of squares pattern. And then here I have sine squared, cosine squared. So this right here, this is equal to 1. Okay, so that almost like cancels out. It's equal to 1. And then I can write cosine squared minus sine squared. And then over sine squared, cosine squared. Okay, so let's see how much farther I want to take this. If we're saying that we want to write it in terms of sine, and quite possibly that means we want to write it in terms of sine only, so we can simplify that down quite a bit. We actually might want to just leave it here. That seems like it's about as far as that will go. So yeah, we're just going to leave that.